Good morning, guys. Today we're going to be graphing quadratic functions. So we're going to be using the skills that we've used before when we were graphing absolute functions. So we're going to be translating, reflecting, dilating, and expanding. So we're going to be able to graph quadratic functions using transformations and be able to identify some of the key attributes that the quadratic function has. Then we're going to be able to write the equation of a quadratic function given its description. Given if I give you a transformation, could you give me the equation of a quadratic function? And then the last thing, be able to write the equation given a graph of a quadratic. And again, these are things that we've done before, but we did them with the absolute value. So let's see, introduction. Today we're going to begin our study of the quadratic function. We will review graphing using transformations, and we'll look at the function's key attributes. So let me scroll down here, zoom out a little bit. Okay, so if I give you the function of a quadratic, it'll be f of x equals x squared. And some of the points that are related to the quadratic are some of the main, it has 5 main points. It's -2, 4, and basically I'm plugging in -2. What's -2 times -2? That's +4. Then there's another point in there that's -1. If I multiply -1 times -1, because it's squared, right? A number times itself, -1 times -1 gives me +1. Then 0 times 0 gives me 0. 1 times 1 gives me 1. And 2 times 2 gives me 4. Okay, so these points are the following. So I'm going to color them in blue. So 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. Which give us the following. Make these dots a little bit bigger. And so the vertex here is 0, 0. Actually, let me use a different color. Let's use purple. So purple right there is 0, 0. The root, where it hits the x-intercept, is also at 0, 0. The domain, if I go from left to right, the arrow is going to the left towards -infinity, and the arrow on the right is going towards +infinity. So my domain is going to be -infinity to +infinity. And a little disclaimer, the domain is always going to be the same for quadratics. So it's always going to be -infinity to +infinity. The range is the one that's going to change depending on the equation. But the range for this one, if I go from bottom to top, it goes from the lowest point it goes is 0, and then it goes up towards infinity. So we put a bracket for 0 and infinity with parentheses. And there's, I think, 2 more things on the bottom. Actually, one more thing. Where is the minimum or maximum of this point? Do we have a minimum or maximum? Do we have a lowest point? Because the arrows go up towards infinity, so there's not really a highest point because these arrows are going to keep going and not stop. But there is a defined minimum point. So I'm going to write minimum there's a minimum of what's the lowest y value that it goes? Minimum of 0 at x equals, at x equals 0. So this is like the y value. It's like the y value. So at y equals 0, there's a minimum of a height of y equals 0 at the point x equals 0. All right. So this is the quadratic function. This is how it looks as an equation. What are the 5 main points? What consider the vertex, the zeros, remember those are the x-intercepts, the main range, and minimum or maximum. So these are the key attributes of the quadratic. These are the things that we're going to keep bringing up as we look at different equations and graph different equations of quadratics. And so let's look at the first example. Oh, sorry, before we go to the first example, let's look at the transformations again. So some of the things that, if you remember from absolute value, if you're adding or subtracting inside of the absolute value, or inside of the function, in this case the quadratic function, that tells you if you're going to the left or the right. If you're adding, then you're going to the left. If you're subtracting, you're going to the right. And so horizontal translations are opposite, but vertical translations happen outside of the function. So you're either subtracting or adding. If you're subtracting, you're going down. If you're adding, you're going up. And again, I'm not going to spend too much time on these because they're the same transformations that we saw with absolute value. There's only one type of reflection here, which is reflection over the x-axis. Remember the absolute value had 2 types of reflections, over the x-axis or the y-axis. For this one, it's only over the x-axis, and that happens when there's a negative in front of the quadratic function. And in the last 2 transformations here, there could be a vertical expansion or vertical compression. Notice that there's only vertical, there's no horizontal in this case. So vertical expansion happens when you multiply the function by a number that's bigger than 1, and vertical compression, it gets smaller if you multiply the function by some sort of fraction. Okay, so if you multiply by a large whole number, it's going to stretch out the quadratic function, stretch it up vertically. If you multiply by a fraction, it's going to kind of squish it and make it expand, vertically compress, which expands horizontally. Okay, and we'll see how that looks like in the different examples that we cover. And the instructions for the first 5 examples, they want us to graph the quadratic functions, then fill in the table with the key attributes of the function. So we're going to graph and fill in like we did at the beginning of the video. So now let's go to example 1. See if I need to zoom out here. Let me zoom out a little bit. That looks good. Okay, so we have x plus 2 squared. Since it's squared, we know it's quadratic. So the quadratic gives it that U shape. the points of the quadratic, if we list them out again, they are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. As far as the translation goes, they are adding 2, so that means a horizontal translation, 2 units, horizontal translation, 2 units to the left. So again, it's a horizontal translation, 2 units left. Okay. And just like before, I'm going to graph the original current points at 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And they're asking us to move these points to the left 2. So that's going to be here. And then the other one is going to move here. And then what I like to do is once I got 0, 0, I'm going to go 1 right, 1 up, then 2 right, 4 up. And then kind of make it symmetrical this way, and then go 2 to the left and 4 up, so right here. So once I got my center point here, I just move that one 2 units to the left, then I go 1, 1, 2, 4, 1, 1, 2, 4. And then I graph my function, which has that U shape, so remember the quadratic has a U shape. And then we identify the different points. So the vertex is that lowest point here. That's going to be at a location of -2, 0. And then the x-intercept is actually at the same location. That doesn't always happen. It just tends to happen in the examples we've been doing. Domain is going from -infinity to +infinity. But the range, it also stays the same because it has a lowest point of 0, lowest point of y equals 0, and it goes up towards infinity. So it's absolute value, a bracket of 0 and infinity with a parenthesis. And then we have a minimum or maximum question. Here we have a minimum of y equals 0 at x equals -2. So again, we have a minimum height. This is, how far low does the graph go? If it does have a minimum, how low is it? It's at a height of 0, y equals 0. But where does that lowest point happen? At x equals -2. Okay. Example 2. Again, we have the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And so that makes up these points, 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And here we see that what's happening is -1. So that is a vertical translation, 1, 1 unit down. Okay, so everything is just shifting 1 unit down. So it's like moving all these points 1 step down. So that's going to leave you here, here, U shape, the U shape. Yes, yeah, that looks like kind of wobbly. But then we have a vertex here. So here we have use a different color since I already have purple there. I'm going to use pink for the vertex. So the vertex is at 0, -1. And then I'm going to use a different color for the roots. Use green. So for the roots or the x-intercepts, they happen here and here. So they're happening at 2 locations, at -1, 0, and 1, 0. So these are the 2 x-intercepts here. Domain, again, always stays the same. It's -infinity to +infinity. But the range changes this time because the lowest point now changes from 0 to -1. So we can put a bracket. -1 is the lowest point. And the highest point, since the arrows are going up, the highest point is +infinity. And then here we have a minimum of a y value of -1 at an x value of 0. Right. So how low does the graph go? It goes to a minimum of -1 at a location of x equals 0. Okay. So now let's go to example 3. Example 3. Again, for the points, it's -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So that's 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. And the translation here is a negative. So there is a reflection over the x-axis. There's a reflection over the x-axis. Alright, so that just causes, zoom out a little bit, that causes the points to just be located in the opposite direction, so going downwards instead of upwards. Okay, and then, so then the vertex is at 0, 0 actually, and the x-intercept is at 0, 0, same location. Domain doesn't change, and it never changes. For the quadratic, the domain never changes, but the range does. So now what's the lowest that the graph goes? It goes as low as -infinity, but it goes as high as 0. So this is 0 with a bracket. So now we have a maximum. Notice I changed the word minimum to maximum now. And we have a maximum of maximum height of 0 at an x location of 0. Okay. And then we're going to go to example 4. So again, the points are negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. That's 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay, so here we have 1/2, and then we have -4. So that means since 1/2 is less than 1, there is a vertical compression. Vertical compression by 1/2. And there is a vertical translation 4 units down. So this is the vertical, the -4 is the vertical, and the vertical translation, and vertical compression by 1/2. Okay, so actually I'm going to move it down. There's actually, yeah, let's move it down first. Or actually, I can compress it first. So if I compress it, it's just like multiplying the heights, cutting them in half. But half of 0 is 0, so the 0 one is going to stay there. Half of 1 is half. So notice I'm cutting this distance in half. Half of 1 is 1/2. What's half of 4? Half of 4 is 2. And so then I copy the location of these points and then move them down down 4. 3, 4. Point. So instead of going one right, one up, I'm going to go 1 right, half up, because I'm cutting the distance in half. Half over here and half over here. Then instead of taking 2 steps to the right and 4 up, I'm going to take 2 steps to the right and half up. So what's half of 4? It's 2. Okay. And there's actually another part of the points that I can use. When I take 3 steps to the right, what's 3 squared? 3 times 3 is 9. So I typically take 9 steps up. But since I'm cutting the height in half. Instead of taking 9 steps up, what's half of 9? It's 4.5. So I'm going to take 3 steps to the right, and instead of taking 9 steps up, I'm going to take 4.5 steps up. So I have 1, 2, 3, 4.5. So my graph's going to look something like this. And let me see if I can do the other half as smooth. I'm actually proud of this curve. It's pretty smooth. And now my vertex is this point right here, which is at 0, -4. My x-intercepts are these green points here. So I'm going to round where they're at. So I'm going to say that it looks like it's at -3, 0, and 3, 0. Domain does not change for quadratics. It's going to stay -infinity to positive. The range is going to go as low as -4. So bracket -4 to a height of positive infinity. So here we have a minimum of -4 happening at an x value of 0. At x equals 0, if I go to x equals 0, the graph goes as low as -4. Alright, so then let's go to example 5. Zoom out a little bit so we can see the full graph. Okay, so here we have a couple things happening. We have a negative in front, so there's a reflection. Then there's a -3, and then there's a +4. So that means means that there's a reflection over the x-axis. The green means that there's a horizontal translation 3 to the right, and there is a vertical translation 4 up. So I have the reflection over the x-axis is this red part that I colored in the equation. Then there's a horizontal translation to the right, 3 units, and a vertical translation 4 units up. So the points are going to be -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So these are my parent points. Then we're going to reflect. And then I'm going to erase black points so that I just have the reflection points. Then we're going to move 3 to the right and 4 up. So 1, 2, 3, and 4 up. So 1, 2, 3, 4. Okay, and so from there, the graph's going to go 1, 1, 2, 4, right? So it's 1, 1, then 2, 4. Oh, and then, sorry, over here. It'll be over here. So let me just double check. We're going to go 1, 1, and then 2, 4, 1, 1, and 2, 4. And let me go ahead and delete these red points and these purple points. There we go. And then we're going to connect to make the graph this way and the graph this way. Okay, so then we have a vertex. Vertex is up here. The vertex is at 3, 4. Then we have two x-intercepts, one here, one here. That happens at 1, 0, and at 5, 0. The domain is negative infinity to positive infinity. The range is from negative infinity, it goes as low as negative infinity, to a maximum height of 4, the bracket. So there is a maximum of 4 at x equals, I want to write x equals, but x equals is already written. So maximum height of 4 at x equals 3. All right, and then we have x equals 6 and 7. Examples 6 and 7, not x equals. But examples 6 and 7, quadratic. So the fact that it says quadratic just means that we're going to be using x squared. Translates 3 units to the right. And then we have 7 units up. So that's plus 7. 3 units to the right means minus 3. And expands vertically by a factor of 2. So multiply by 2. Okay, so the equation is going to look like f of x equals multiplying by 2. Then we're doing parentheses x minus 3, close parentheses, and then we're raising it to the power of 2 because it's quadratic, and then a plus 7 on the outside. So this is my function. And then translate 6 units left. So that's plus 6. Then reflect over the x-axis, so that's putting a negative, and then vertically compressed by a factor of 1/2. That means multiply by 1/2, so a negative 1/2. So my function is going to equal to a negative 1/2, then x plus 6, then to the power of 2. Right? And if I write everything without colors, be x minus 3 squared plus 7. And then on the example 7, it would be negative 1 over 2 parentheses x plus 6 squared. Okay. And then we have examples 8, 8 and 9, I believe, on this side. So these two, it says, write the equation of the quadratic function that describes the graphs displayed below. So, if we notice, we can see how many steps to the left, how many steps to the right do we take. So we took 1, 2, 3 steps to the right, because our starting point is right here at 0, 0. So if my starting point is at 0, 0, this blue graph went 1, 2, 3 steps to the left, and 1, 2, 3, 4, 5 steps down. So it went 3 to the left, 4 down. What's the spacing in the points, right? If it's at 0, 0, then we go 1, 1, 1, 1, 1, 1, 1, 1, and then does it go 2, 1, 2, 3, 2, 4, 2, 4. Okay, so there's no compression or expansion. Did the graph flip? Did it reflect? Is it going downwards? No. So the equation or the function will be x plus 3, which means that it went to the left 3 squared, and then it went 5 down, so that's minus 5. Then we look at example 9. If my starting point is at 0, 0, it looks like it went 1, 2, 3 steps to the right. 2, 3. It looks like it's reflected downwards, so there's a negative because there's reflection downwards. And then the spacing between the points, right? If this is my vertex is at this location, then does it go 1, 1 and 2, 1, 2, 3, 4? Yeah, it looks like it goes 1, 1, 1, 1 on either side, then it goes 2, 4, 2, 4. So the spacing is good. So the function would be f of x equals, there's a negative in front with x minus 3 squared. Right, minus 3 because we went to the right 3, and there's a negative in front because there's a reflection. So that brings me to the end of the examples. So thank you for joining me in this video for today. Coming back to graphing. So we're having to brush up on the rules of graphing. But thank you for joining me today. I'll see you guys in class, and if you have any questions, feel free to bring them up. Have a great day, guys.